Good evening. Tonight we're going to do the notes for day 1 in the packet. I will learn to identify and graph linear equations. Let me tell you what I've learned so far making these videos, that when I take the time to actually write out the notes while I'm talking, it actually takes more time and it will make your video longer. So I'm going to pre-write some things and write some things as we go, and there might be some pauses in the video, some fade-ins and fade-outs, and we'll see how that goes as time goes on. So what we're going to talk about is the linear equations. So a linear equation is an equation whose solution fall on the line on the coordinate plane. And if you recall from earlier in the year, we talked about coordinate planes where we had an x-axis and a y-axis. Now remember, where the two lines meet is called the origin. It has coordinates of 0, 0. Going back to the linear equations, an equation whose solutions fall on a line on the coordinate plane. This would be the line on the coordinate plane in red, and the solutions are marked in blue. Remember earlier in the year when we made tables with x, y values, and we'd plug in an x value. For example, we'd plug in a 2, and we'd run the numbers and we calculate a y value of 2. And so we would make 2, 2 the ordered pair, and then we'd plot that line on the graph. This point has the ordered pair of 1, 1, and its x value is 1, and its y value is also 1. This last blue point is on the origin itself, so its x value is 0, y value of 0, ordered pair is 0, 0. Here we are with the first example, y equals 3x minus 4. We want to make a data table, and we want to make a little coordinate plane graph here because we're going to use both of these. So if you want to pause and go ahead and sketch those out, that might be a good idea. What we want to do with y equals 3x minus 4 is we want to see if it's a linear equation. So we'll make a table of values, and then we'll plot them on the y-axis and see if we make a line. So first values we'll pick. X will equal 0, 1, 2, and 3. 3 times 0 minus 4 equals negative 4. Ordered pair, 0 minus 4. 3 times 1 minus 4. Y equals negative 1. Ordered pair, 1 minus 1. 2, oops, that should be a 3. 3 times 2 minus 4. Y value is 2. Ordered pair is 2, 2. And finally, 3 times 3 minus 4 is 9 minus 4. Y value is 5. The ordered pair is 3, 5. Now we're going to graph these on the XY axis. I've zoomed the camera in so you can see these a little bit better. And let's go. Let's plot the first point as 0 minus 4. We start at the origin, 0. We're not going to go in either direction because the x value is 0, but the y value is negative 4. So 0 and then down 4 steps. 1, 2, 3, 4. 0, negative 4. The next value was 1, negative 1. First of all, let me go back here and label this. 0, negative 4. The next ordered pair was 1, negative 1. So we go to x equals 1, y equals negative 1. Make the point. Label it. Next ordered pair was 2, 2. We go over 2 steps and up 2 steps. Label it. 2, 2. The last point we had was 3, 5. Oops, I didn't put a 5 on there. 5 would be up here about. So go over to 3 and up to 5. That point would be right about there. We're going to connect all of these points with a straight edge. Oh, it's a sketch, so they're a little bit off, but it should be pretty close. So we see that the linear equation y equals 3x minus 4 is shown by this red line. And I'll pan back out. There's our equation. Y equals 3x minus 4. We took all of the ordered pairs that we calculated, we plotted them on the graph, and drew a line. So we can say that this equation is a linear equation. End of example 1. Every time that we have a change in the x value, so for instance, from 0 to 1, a change of 1 in the x value resulted in a change of 3 in the y value. So when we went from this point, we changed 1 in the x direction and we changed 3 in the y direction. With the next point, we changed 1 in the x direction and then we changed 1, 2, 3 in the y direction. And the same for the last point. Change in 1 in x resulted in a change in 1, 2, 3 in y. So if an equation is linear, a constant change in the x value, like we talked about, a change of 1, corresponds to a constant change in the y value, the change of 3. Every time we changed x 1 position, we changed y 3. Here's example number 2. The equation is y equals x squared. I've made a data table. I have made an xy graph. You may want to pause the video and do that as well. We're going to test out this equation and we're going to see if its solutions form a line. Pick the x values of -2, -1, 0, 1, and 2 to try out. Remember, negative means the opposite of. So the opposite of -2 squared equals -4. Our ordered pair is -2, -4. The opposite of -1 squared is -1. Ordered pair, -1, -1. And we keep going. The opposite of positive 1 squared is -1. And the opposite of positive 2 squared is a -4. Ordered pair 2, 4. Now we want to do just what we did last time, and we're going to take our ordered pairs that we got out of our data table, and we're going to plot them on this XY graph. I'm going to zoom up a little bit like I did last time so we can see a little bit better. So, first pair is -2, -4. So I'll go over to x equals -2 and down to x equals -4, -2, -4. Next point, -1, -1. The next point is right on the origin. It is 0, 0. Next point is +1, -1. Go to positive x equals 1, down to y equals -1. And lastly, oops, that's a mistake right there. Last point is 2, -4. So x equals +2, y equals -4. It will be right about there. Now we're going to connect these points. And right away when we do this, we can see this isn't a line, is it? It's like an upside down curve. In fact, this is what we call a parabola. But the important thing here is that this is not a line, so this is not a linear equation. Not a linear equation. Pan back out because I wrote that up there. Okay, we'll be back in a minute with one more example. Welcome back. We have example 3. If you want to take a moment and sketch out the data table and the axis. The equation we're going to test is y equals -3. Test and see if it is a linear equation. So let's try some x values of -1, negative 2, negative 1, 0, 1, and 2. Okay, so y equals negative 3. There is no place to put an x. So no matter what I have for an x, negative 3 is still going to be negative 3, which means that y is still going to be negative 3, which means this ordered pair will be negative 2, negative 3. Same for the next value. Oops. Negative 3, negative 3, ordered pairs negative 1, negative 3. And the pattern continues. There is no place to put an x value, so whatever I put in for an x value, I will always get negative 3 as the y value. So if I go and plot these points like we did times before, I can see that negative 2, negative 3 will fall right about there. Negative 1, negative 3 is here. 0, negative 3, 1, negative 3, and 2, negative 3. So if I take and connect these points, I can see that I do have a line. So y equals negative 3 is a linear equation. Okay, let's wrap this up. So for tomorrow, I would like you to, in your notes here, I would like you to write down the equation y equals x plus 1. I want you to make the table like we did, and the graph, and then I want you to connect the points and tell me if the graph is linear. So tell me whether or not this is a linear equation.